Okay, so I'm going to take a look at a specific type of series here, something called a telescoping series, and which is a series which most of the terms cancel out. All right, so let's go over a couple of examples here. So the goal here is I want to determine whether the following series, e to 1 over n, 1 over n plus 1, whether it converges or diverges. All right, so I'll start by looking at the partial sums. Right, so when it's the first term, it's just e to the 1 minus e to the 1/2, right? N plus 1. So let me write that a little clearer. Okay, now if I look at the second term, we get e to the 1, so first term, same as before. Then the second term, when n is 2, we get plus e to the 1/2. Excuse me. This one is minus. That's what's going to make it telescoping. Minus e to the 1/3. All right, and we notice here that those middle terms cancel out, and we're left with e to the first power minus e to the 1/3. All right, let's do one more, and I think we can probably establish a pattern here. All right, so e to the 3 would look like this. Right, first terms as before, and then for the third one, plus e to the 1/3 minus e to the 1/4. And notice here that in this case also the middle terms cancel out, and we're left with this. All right, so it looks like the kth partial sum here is just e, right? Looks that shows up the first term, and I'm left with the last term, and the last term is always 1 over k plus 1. All right, you see here for 1, it's a half. For 2 is 1/3. 3 is 1/4. So it looks like this is my formula. All right, so now I can evaluate the sum, right? I could say here that the sum s is the limit as k goes to infinity of these k partial sums, which is the limit as k goes to infinity of e, which is just a constant, minus e to the 1 over k plus 1. All right, and we see what's happening here, right? As k goes to infinity, right, this number 1 over, right, a very large number, right? So that is tending to 0. Right, but be careful, right? That's in the exponent, right? So the exponent is tending to 0. So e to the 0 is going to be 1. So we're left with this, right? A finite value, right? Which means that now, putting this together, we've established that this telescoping series is equal to e minus 1, right? And again, finite value. So what does that tell me? That this is a convergent sequence. Okay, so let's take a look at one more example here. I know, and again, it's the same thing that we want to do. I want to determine whether the series is convergent or divergent. Now I'm going to rewrite this so we can see the kind of telescoping nature of this using properties of logarithms. Okay, and then again I'll start by just writing the first few partial sums and then determining some pattern, right? So s of 1 would be ln of 1 minus ln of 2, right? N and n plus 1. And again, recall ln of 1 is 0, so we're left with negative ln of 2. S of 2 is, again, s of 1. And then a2 would be ln of 2 minus ln of 3. Right, and we get, again, ln of 1 is 0. The middle terms cancel out as well. They go to 0, so we get negative ln of 3. All right, and let's do one more to see if the third one does agree with the pattern that is going to happen here. Ln of 1 minus ln of 2 plus ln of 2 minus ln of 3 and then plus ln of 3 minus ln of 4. And we see again ln of 1 is 0, and then the middle terms again cancel each other out, so we get negative ln of 4. All right, now it looks like the kth partial sum is negative ln of k plus 1. Right, so whatever k is, as we saw here, when it's 1, it was ln of 2. When it's 2, ln of 3. When it's 3, ln of 4, etc., right? Okay, so let's see if I can find the limit of this sequence, right? The kth partial sum sequence. So again, that comes from taking the limit as s sub k as k goes to infinity, or the limit as k goes to infinity of negative ln of k plus 1. The natural log is an increasing function, so as k goes to infinity, so does the natural log. We have a negative in front of it, so it goes to negative infinity. So here it is not a finite value. It does not converge to anything, any real number, I should say, not anything. So therefore we can conclude that the series ln of n over n plus 1 is divergent, since it does not go to a finite value.